In the last video, we learned about the input function in Python, which allows you to get user input from the keyboard and returns what the user types as a string. We saw that the output of the input function really is always a string, even if you just type 2 digits, like 22. That's a problem if you want to actually work with the user's input as if it were a number. So to do that, you need to actually convert the string, which the input function returns, into a number. Converting between types is called casting. So what we needed to do in our example was to convert a string to a numeric variable. The string 22 in quotes and the number 22 are two different things. To demonstrate that, I'm going to run this first code cell where I ask Python, is the string 22 equal to the number 22? It will tell me false. In fact, we already knew this because we tried to add one of our strings containing digits to a number, and we saw that Python gave us an error because it didn't know how to add a string to a number. Now, sometimes, like in the situation I've been talking about, we need to convert a string which represents a number into an actual number. For example, if you wanted to do a comparison or we wanted to do arithmetic with that number. The easiest way to do this is when your string just consists of digits. In that case, you can convert your string into an integer using the int function. In the next code cell, I define a to be the string containing the characters 2 and 2. And in the next line, I use the int function on a. That will return the number 22. To show you that it really is the number 22, I've used it in a sum. So the output here will be the number 30. As you can see, that's worked. On the other hand, if you want to convert a string which consists of a decimal number, like 2.22, you need to use the float function. The float function can take a string as input and will return what's called a floating point number, which you should think of as a number with a decimal point. Here, if I call float and then quotes 2.22, the answer will be the number 2.22. And just to demonstrate that, in the next cell, I'll do some arithmetic with the output of the float command. So here we go. The float function applied to quotes 1.5 gives me the number 1.5. When I add 1 to that, I get 2.5. What you can see there is that actually Python has more than one type of number. It has a type called int, which represents an integer, a whole number, and a float, which represents a number with a decimal point. Python will actually automatically convert between those two without bothering you about it. For example, you're perfectly free in Python to write 1 plus 1.5. Now the 1 there is an int and the 1.5 is a float, but Python will automatically convert the 1 to a float in order to do this sum without making any errors. So most of the time, you won't ever have to think about the difference between an int and a float. You can also convert in the other direction. If you want to convert a number to a string, you can use the str, short for string, function. To see why you might want to do that, let's say you wanted to take the string 1, 2 and add on 3 to the end. This will give us an error because you're then trying to add a string and an integer. But if you remember to use the str function to convert 3 into the string quotes 3 quotes, this will work just fine and give you the result 1, 2, then the digit 3 as a string. Now we've learned how to convert between strings and numbers, let's try to play a game. So the game we're going to play is called higher or lower. In the higher or lower game, one person thinks of a number between 1 and 100, and that person in our game will be the computer, and the other person tries to guess their number. And each time they guess, the first person has to tell them if their guess was too small, or if it was too big, or if it was correct. So to simulate the computer thinking of a number at random, I'm going to use a little bit of code which we won't understand just yet. This code in the code cell I've just selected produces a random whole number between 1 and 100 inclusive. You'll learn about random and about the import command later on. For now, just treat this as something which will produce a random number between 1 and 100 inclusive. So now secret holds a secret number between 1 and 100, and we're going to write a function which allows us to play a game trying to guess that number. So what should we do? Well, we need to get the guess from the person playing the game. So in order to do that, we'll have to use the input command. That's the only way we know to interact with somebody using our computer. So let's say guess is equal to input enter your guess. So all that does is print out the message, enter your guess, and then give you the chance to type something in. So if I do this, then it will ask me to enter a guess. I can do this. I could type 34. But of course, we've got this problem which we had before, which is that the output of the input command is always a string. So in fact, the guess variable now is the string 34. We can see this by using the type function. It's a string. But we want to compare our guess with the secret number. So we need to turn this guess into an actual numerical Python variable. We can do that with the int command, assuming that our user is sensible and types in an integer. So let's take the result of that input function and apply the int function to it. Now the guess will be stored as an integer, and we can start to compare it with the secret number. So now when I type 34 and ask for the type of guess, you can see we've successfully turned the user's input into an int, or an integer. So let's move on with our program. Now we've managed to get the guess from the user. We want to compare it with the secret. So to do that, we need to use a conditional, which we learnt about a couple of lectures ago, and we need to use comparisons, which we learnt about in our lecture about Booleans. So what we should do is think about what happens if guess is less than the secret. So I need to type if, and then a condition which should be true or false. In this case, guess is less than secret. Then on the next line, I need to indent the code which I want to happen if that condition is true. So if that condition is true, the guess was wrong. The guess was too small, so we should print out a message saying too small. Okay, now I need two more cases. I need one case for when the guess was too big and another case for when the guess was correct. To add another case in Python, you'll remember that we use elif. So elif, guess is greater than secret. Okay, this time, if the guess was greater than the secret, again, all I want to do is print a message, and I'm going to say too large. Finally, if neither of those two conditions was true, then actually the guess must be correct. So the way we can deal with that is by having else, which will be, and the meaning of this is that the indented code following the else will be executed if neither of the first two conditions was true. If neither of those first two conditions, that guess was less than secret and guess was bigger than secret, is true, then guess must be equal to secret, so the guess was correct. Print, in this case, you win. Okay, so we're ready to go on our guessing game. Let's try it and see what happens. Enter your guess. We'll just try it. 34 again. Too small. Okay. Let's try again. 34 was too small. Well, a sensible first choice is really 50, isn't it? So 50 is also too small. Let's now have a sensible guess again. 75, too small. 87, too large. So it's somewhere between 75 and 87. You get the idea. I could keep going forever until I get the right answer. And it does seem as if this is working. Let's cheat just to see what the real answer was. Secret was 81. Okay. So there was one real problem with the way I implemented this game, which was that it didn't just keep asking and asking and asking until I got it right. What it did instead was that I had to rerun the code cell every time I wanted to enter a new guess. So one solution to that would be simply to copy and paste. If I copy and paste this, then I get 2 rounds of the game. But even this doesn't work, because firstly, it's probably going to take me more than 2 rounds. Secondly, it's really bad to repeat yourself. Repeating code is always a terrible idea, because if you find a mistake in one little bit of the code, you then have to correct that mistake 2 or 3 or 1,000 different times. That's why it's always better to avoid repeating yourself, if possible, when you're writing computer programs. And finally, this just doesn't work, because we need the game to stop if I guess correctly. But at the moment, if I guess correctly on the first go, then I would still be asked to guess again because of my copied and pasted code. So we have a real problem here. We need a way in Python that allows us to repeat certain pieces of code until a condition is met, in this case, until the guess is correct. Repeating code is dealt with in Python by what's called a loop, and loops are going to be the subject of our next two videos.